My name is Julie Brunning. I'm a part-time master's student at Cardiff University doing environmental design facilities. I'm just about to go into my second year there. So urban outdoor spaces are integral to vibrant cities, but the increase in temperatures are making these uncomfortable and are being used less. This study is looking at a specific area in Hyderabad, India, and a case study of a memorial site with a focus on climate data and thermal comfort analysis to inform microclimatic responsive design. And it's proposing two new spaces to the site, which is a community allotment area and a meditation space. And the aim is to enhance year-round usability of these spaces through the design. The methodology was broken into 6 areas: data collection, microclimate analysis, looking at the outputs, the design priorities, the design iteration, and the design proposal. The EPW data was taken from Hyderabad Airport, which is about 13 kilometres away from the site. There was a bit of research that showed there could be a 2-degree difference in temperature, but no humidity data was collected for the difference between the two sites. It's a composite climate, and the data showed high summers and cooler winters, with humid monsoon periods, and high rainfall. There's also high solar radiation and UV exposure and high levels of pollution on the site. So a bioclimatic chart was used to assess the information, looking at the temperature and humidity, and the monthly data showed that there was extremes across the comfort zone for every month. Further research did also show there might be some adaptive comfort for the individuals in Hyderabad, and that was applied to the bioclimatic chart and used for comparisons later in the project. Due to the extremes going across the comfort zone, I looked into the hourly analysis of the site. And that was used to look at what was required for each hour to achieve comfort, looking at the moisture, the wind speed, required radiation, and any high humidity. And just taking a closer look at that, it showed that there was a higher, the comfort was achieved in the mornings, but there was also some radiation required to achieve comfort. It showed that high wind speeds were required year-round, but these often went above the 5 metres per second comfort limits. Some humidity boost was required, and it also showed that there were some daily extremes from having cold mornings to hot afternoons, and also high and low humidity in the same day. To have a look at what was available on site and use the available surroundings, did further studies looking at where the shade was available, so I could use that the best I could to choose the location. And also I looked at the prevailing winds on the site and used this, applied this to the CFD model to see what the airflow was in the surrounding areas. This information was put into a mismatch table to look at what was available compared to what was required within each hour across the different seasons. And that led to choosing the priorities of the project. This involved further literature study to look at the potential of different materials for the shade, as well as the orientation and the location of where that shade would go. Explore different shapes and also different materials for the temperature regulation to see which could provide the heat in the cooler weather, and the coolness in the warmer weather. Explore different evaporative cooling methods and tested several wind configuration wind walls using CFD. The final design proposal was a butterfly ferrocement roof, which was situated against the western wall, which took advantage of the morning sun for the solar radiation, and that protected it against the afternoon sun and also the monsoon western winds. The shape allowed for increased rain collection and increased airflow. And the water features replaced lee side of the controlled wind, providing evaporative cooling. The communal gardens were vertical and channeled the wind towards the site, offering increased biodiversity, reduction in pollution and noise buffers. And the rammed earth allowed heat to be provided to the plants in the cooler weather, as well as cool seating areas. And the vertical farming provided social sustainability for the local community. The results show that the wind walls didn't increase the wind too significantly, but they did channel the airflow towards the activity area, allowing for the phantom stuff and the evaporative cooling. And the ferrocement offered decrease in solar load and limited UV exposure, but it did allow for the morning sun to heat for the morning activities. It also offered a decrease in the pollution levels. This showed a shift in the bioclimatic chart in the comfort zone, and when applied to the hourly breakdown, the darker green area showed where comfort was achieved. Obviously, it was increased in the other areas also. I did apply the 2-degree temperature difference from the research to the chart, and also the potential adaptive human comfort from the Hyderabad points. So the hourly site-specific did allow for microclimatic analysis to show some improvement in the optimising the comfort throughout the day, using the passive and responsive design strategies, and it did bring other benefits to the site also. However, some mechanical intervention will be needed in the extreme conditions.